In this video, I will explain how to solve an intertemporal choice problem in economics in which we want to maximize a consumer's utility over two different time periods. So let's jump right into an example. This says, suppose a consumer has the utility function U, the utility, is equal to C1 times C2, where C1 represents the consumption level in period 1, and C2 represents the consumption level in period 2. Assume there is no inflation, the interest rate is R equals 5%, so this is the rate at which the consumer can borrow money or the rate at which they can earn interest on their savings. And the consumer has an income of $100 in period 1 and $110.25 in period 2. Find the utility maximizing values of C1 and C2. So we have a situation where the consumer is going to earn different income in two different periods, and we want to know, in order to maximize their utility, what should their consumption level be in each of these periods? So the way that we're going to start solving this problem is by recognizing the following fact, and that is the consumption level in period 2, so C2, it's going to be equal to the period 2 income plus any savings from period 1 plus any interest earned on those savings from period 1. So to write that using some notation, we can say C2 is going to be equal to period 2 income. We can write M2 for that. So that will represent the income from period 2 plus the savings from period 1. That's going to be equal to the income from period 1, so M1, minus C1, so our consumption level from period 1. So the difference between these two values represents the savings that we have from period 1. And then lastly, we're going to have the interest earned on those savings. So that's going to be R times those savings. So M1 minus C1. Now we can simplify this a little bit by rewriting it as C2 is equal to M2 plus, we can recognize that there's just a coefficient of 1 right here outside these parentheses. So we can rewrite this as 1 plus R times, we're multiplying by the same value in both parentheses. So we'll say times M1 minus C1. Now this equation right here is known as our budget line equation. And it tells us the value of C2, so the consumption level in C2, based on what we decided to consume in period 1, so C1. Now, from this equation, we can also write our budget constraint. So the way we write the budget constraint equation is we want to get all of the C's, so all the consumption levels on one side of the equation, and all of the M's, all of the income on the other side of the equation. So let's start by dividing every term in this equation by 1 plus R. So we'll get C2 over 1 plus R is equal to M2 over 1 plus R. And when we divide this term by 1 plus R, it will just cancel out. So we'll be left with plus M1 minus C1. Now remember, we said to write the budget constraint, we want all of the C's on one side. So let's go ahead and just add a C1 to both sides. So here's what we get when we do that. C1 plus C2 over 1 plus R is equal to M2 over 1 plus R plus M1. This is our budget constraint equation. So this equation tells us what our consumption levels can be based on our income from period 1 and period 2. And we'll see that we're going to use this equation later on when we're solving this problem. So I'm going to clear a little bit of space here and rewrite these budget line and budget constraint equations. Okay, so here is our budget line equation and here's our budget constraint equation. Next, we need to recognize that the consumer will be able to maximize their utility when the following is true. Their marginal rate of substitution is equal to the negative slope of the budget line. So let's start by finding what is the marginal rate of substitution. Well, that's going to be equal to the following. The marginal utility of the consumption from period 1 divided by the marginal utility of the consumption from period 2. So the way we find the marginal utility of consumption from period 1 is we take the derivative of the utility function with respect to C1. And the way we find the marginal utility of the consumption from period 2 is we take the derivative of the utility function with respect to C2. So if we consider the utility function right here, the derivative of this function with respect to C1, well, the derivative of C1, that would just become 1. So the derivative would just be C2. And similarly, the derivative of the utility function with respect to C2, the derivative of this function with respect to C2, the derivative of C2 would just be 1. So this whole thing would just be C1. So the marginal rate of substitution is C2 over C1. Now we need to find the negative slope of the budget line. So let's write that down here. Okay, so the slope of the budget line, that's going to be equal to the derivative of C2, so this function we found earlier, with respect to C1. So the derivative of this function with respect to C1, let's go ahead and rewrite that as C2 is equal to M2 plus, let's go ahead and distribute this 1 plus R into the parentheses. So we would get M1 minus C1 plus R times M1 minus R times C1. So the derivative of this function with respect to C1, that would be negative 1. So the derivative of this term is negative 1. And then the derivative of this term with respect to C1, that would just be negative R. And if we pull out a negative sign, this is the same as negative 1 plus R. So we said to maximize utility, we need to set this value equal to the negative of this value. So the negative of this value would just be 1 plus R. So we will maximize utility when the following is true. C2 over C1 is equal to 1 plus R. Now what we can do is we can solve for C2. So we can say that C2 is equal to C1 times 1 plus R. And we know that R, our interest rate, is 5%. So as a decimal, that's 0.05. So we can say C2 is equal to 1.05 times C1. Now what we can do is we can take this value for C2 and we can plug it into our budget constraint. So when we do that, here's what we get. C1 plus, for C2, we're plugging in a 1.05 C1. So we get 1.05 C1 divided by, here we have 1 plus R. We said R is 0.05. So 1 plus 0.05 is just 1.05 is equal to, now for M2, that's our income during period 2, which is 110.25. So we have 110.25 divided by, again, we have 1 plus R. So this is 1.05 plus we have M1, our income from period 1, which is 100. So what we get is these 1.05s will cancel out right here, and we'll have C1 plus C1, so that's 2C1. So let's say 2C1 is equal to 110.25 divided by 1.05. That turns out to be 105. We have 105 plus 100, which is 205. So let's write 205 right here. And lastly, we can see that we can solve for C1 by dividing both sides by 2. So we'll find that C1 is equal to 102.5. So this is our consumption level for period 1. To find our consumption level for period 2, we can just plug it into this equation right here. So when we do that, we get 1.05 times 102.5. That turns out to be C2 is equal to, that's 107.625. Here is our consumption level in both periods. Now, here's what that actually means. Okay, so here are our final answers. The consumption level in period 1 is $102.50, and the consumption level in period 2 will be $107.62.5. So in the real world, we would round this up to 63 cents. But notice that this example says our income was $100 in period 1, and yet in our answer we're saying we're going to spend $102.50. So what this means is that the consumer will choose to borrow $2.50 so that they have enough money to make this consumption level possible. So they'll borrow that amount in period 1, then they will pay off the $250 at the 5% interest rate. So that would be $250 plus 5% of $250 is 0.125, so a total of $2.625, which is why they only had, remember their income from period 2 was 110, but once we subtract that amount, so that borrowed money plus the interest that they had to pay off, they're only left with $107.625 to spend in period 2. So that is the general process of how you can solve an intertemporal choice problem in which a consumer is trying to maximize their utility over two different time periods.